Hello, Drew. Today I'd like to present my podcast assignment of the course Digital Media and Information Literacy. Regarding my assignment, the book I chosen from our course website is Critical Question for Big Data, which is written by Dana Boyd and Kate Crawford. The second literature which I found is named Big Data for Education, Data Mining, Data Analytics, and the Web Dashboard, written by Darren. Here is my content of my presentation. For Literature 1, I will give an overview at first and then introduce the 6 critical questions and then give some comments. For the Literature 2, as the same as the Literature 1, I will give an overdraft first and then introduce some mining, data analytics, and then give comments. The overview of this literature is this literature is a critical article. It mainly illustrates as the era of big data is underway. Big data is an increasingly popular research tool in many academic fields. Nevertheless, some the rise of popularity of big data. This literature focuses on the 6 main critical questions for the big data. The first question is big data changes the definition of knowledge. In the first main critical question, author quotes the Fordism at the beginning. Fordism was a new set of tools to manufacture. Fordism meant automation and assembly lines. When they became the main manufacturing method, skilled craftspeople and slow work was no more important. It means that Fordism changed the manufacturing model. Similar to Ford changed the way we made cars. Big data is not only a tool that we change, but also the changing of the older system of knowledge happens in the meanwhile. In addition, the author pointed out the other method for ascertaining why people do, write, or make things are lost in the sheer volume of number with big data becomes popular. This is not space that have been welcome to older forms of intelligential craft. Last but not the least, before the big data becomes the majority research method, the own inbuilt limitation of big data must be taken into account. My comment on this question is that the author quotes the Fordism to state that when we change the tool, we also change the model and the method. It's proper. We must consider influence of the changing of the system of the knowledge. However, the author didn't point out the limitation of the Fordism. This makes less persuasion for the author's point of the limitation of big data must be taken into account, as we also can see the bad aspect of the changing of the system of knowledge. The second question is claims to objectivity and accuracy are misleading. At the beginning of this part, author quoted the Leto's view that in social domain there is a line between what is and what is not quantifiable knowledge. After that, the author illustrates that in real world, working with big data is still subjective. As an example, we consider a message from social media. People filter the message subjectively and use this message to produce facts as the interpretation at the center of data analysis. Regardless of the size of the data, it is subject to limitation and bias. This will lead to misinterpretation. My comments on the second question is, when we consider about the research, the subjective judgment is always there. Working with big data will enlarge this problem, and it can be applied in many object reports. One thing that I suppose can be applied for this problem is reduce the number of processes of big data. The less you do, the more objective result you have. Big data presents us with large quantities of data. The understanding of sample is more important than before. To support this point, author quotes an example of Twitter. Twitter provides an example in the context of statistical analysis. This example illustrates 2 critical points. The first point is Twitter does not represent all people, and it is an error to assume people and Twitter users synonymous, which also means big data and whole data are not the same. The second point is it is hard to understand the sample when the source is uncertain. Twitter creates many subsets of its all users, which contains all public tweets, 10% of public tweets, 1% of public tweets, respectively. It is not clear the tweets are included in these different data streams. Without knowing, it is difficult for researchers to make claims about the quantity of the data that they are analyzing. Thus, when we combine multiple data sets, it is increasingly important to recognize the value of small data. My comment on this question is that, indeed, bigger is not always better for data. When the researchers focus on the big data, the small data will be ignored. It is better to think both of big data and small data. When we use big data in our research, it can provide a rough result. Then we apply the small data to make the result more specific and more precise. The fourth question is, taken out of context, big data lost its meaning. As data can be modeled, data are often reduced to what can fit to a mathematical model. Taken out of context, data lose meaning and value. In this part, author refer the social network sites to identify personal connections. Big data introduced two new popular types of social network derived from the data traces: articulate network and behavior networks, which represent two different groups. Both of these two have the great value to the researchers, but they are not equivalent to personal networks. For example, not every connection is equivalent to every other connection, and neither does frequency of the contact indicate strength of relationship. Data are not generic. My comments on this question: the numbers and the quantities outcome cannot hold without any context. We could not measure everything by data. As we know, 10-gram gold is heavier than 1-gram diamond. But if we consider about the value of them, we need some other functions. It cannot present by the numbers. The fifth question is, just because it is accessible does not make it ethical. This part, author focused on the ethical level. The main critical question in this part can be concluded as, what is data, so-called public data and social media sites? Can it simply be used without requesting permissions? As big data represents us with large quantities of data, to admit that it is hard to get permissions from every data provider. Thus, without any permission, in big data mining, the protection of privacy of information is difficult, and no one knows who is responsible for making certain that individuals and communities are not hurt by the research process. My comment: this is most critical question that I grade. Although big data mining needs technologies method to support it can be done, just as same as mineral mining. You could invest money on the technologies, but it doesn't mean that you could own the minerals. The data provider upload their information on website, but it doesn't mean you found it, you own it. It is not ethical. This point is also the reason that Google Glass failed. The last critical question is, limited access to big data creates new digital divide. In author's view, big data was created by every provider and it was collected. But who gets access? For what purpose? In what context? Author gives an example here. The class of the big data rich is reinforcement through the university system. Top-tier universities will be able to buy access to data, and the students from the top universities are the ones most likely to be invited to work within large social media companies. On the other hand, those from periphery are less likely to get those invitations and develop them skills. The result is that the divisions between scholars will widen significantly. This similarity of this example is also significant on some other fields too. The current ecosystem around big data creates a new kind of digital divides, the big data rich and the big data poor. My comment on last critical question. This critical question is more closer to the social problem. As we can see, divides are already. The purpose of using big data is more and more commercial. The more money that they invested, the more data they have. In academic aspect, the author has already given an example for the divide. So typically, pedagogy is faced with several limitations. As far as students are concerned, they receive little immediate feedback and are not proactively showed how to improve comprehension ability. For teachers, they have to spend a great deal of time on student performance assessment. However, the big data makes it possible to study, learn in real time, and provide systematic feedback to students and teachers. And the feedback is crucial for improving learning process. This report illustrates the ways to improve through data mining, data analytics, and web dashboard. The online tools allow the evaluation of wider range of student actions, such as how long they devote to reading and how quickly they master key concepts. The data mining and data analytics software can then provide immediate feedback on students' performance to students and teachers. In this way, teachers are able to analyze the underlying pattern to predict student outcomes such as dropping out, needing extra help, or being capable of more demanding assignments, and then identify most effective pedagogic approach to each particular student. For instance, Vincent Allen and his college ran controlled experiments through intelligent tutoring system. The system sends error message if the students follows an incorrect approach and provide answer hints if requested by the student. Instructors can get a detailed analysis not just of whether students reach the final answer correctly, but how they solve the problem. At the same time, a clear majority of students are reported to prefer online traditional approach. Dashboard software combines data from various streams to present a clear and comprehensive overview of school operations. As an example, Dreambox is a dashboard that aggregates data from administrators. It summarizes proficiency data for each grade level in particular schools. Administrators can compare each grade and see overall how well the students are performing. However, most of these dashboards are not very detailed in terms of individualized learning progress. Yet many barriers complicate the achievement of these benefits. The biggest obstacle are building data sharing networks. Many schools have information systems that do not connect with one another. The fragmented nature of technology inhibits the integration of school information and mining for useful trends. In addition, data ought to be formatted in similar ways so that results can be compared. But too often there is inconsistent terminology or coding on issues related to school dropouts or graduation. My comments on this article is, data mining and data analytics software provide immediate systemic feedback to students and teachers, allowing teachers to identify most effective pedagogic approach to each particular student, which is consistent with personal relevance frame, that learning is about finding personal relevance and meaning, and also consistent with the learning to learn frame. It helps learners construct knowledge appropriated as the system proactively suggests how to improve corresponding ability. In addition, it also indicates the degree to which the students reached the final answer correctly, as well as how they solve the problem, which is in line with the competency frame. All above is the structure and the content of this literature. And I want to say at first why I choose this article to supporting the article which I found on the website of our course literature. Because at first we study in education. This article is that it is using big data to support the learning. And I also found 3 frames that can be applied in here. So at first I want to say I tried my best to retell the content objectively. And now I will illustrate my viewpoint on these literatures. At first, I have to admit that I'm fans of technology. I thought many developing technologies and developing technologies, such as cloud computing, big data, wearable and devices, and so on. I would like to say some extent I agree with others' standpoint, as I have my comments after each question. But I want to say that the speed of development is so rapid that there is no enough time to make proper judgment upon a certain technological development. More often, the technology itself has changed quickly, just like the big data, as the evaluation and adjustment have not been given correctly under such constantly changing conditions. More deficiencies are accumulated, which cannot be disposed in time. This literature let us rethink about the big data, which is quite protected. Indeed, more attention should be paid on the 6 questions and the author gave. I also demonstrate my own opinion in the meantime. What I'm going to say is, it is unnecessary to be bound by these questions. Big data just has the same pace of the development as Fordism does. As far as present, the application of Fordism is still the majority in the most of industries. When big data changes the older system of knowledge, we cannot define it is good or not bad. At least now, we cannot define it. Big data centrally has its pros and cons. What should we do? We give the critical question about it, just like the author did. We weight both advantages and disadvantages and exploit its advantage to the full. When we regarding a developing object, an appropriate reference will be a good evaluation in terms of the past experience. Thanks for your listening.